Do you like sweet smells? Do you like fruits? Do you have organic chemistry? Do you like it? I guess not. Well.
Are you used to writing level 1 answers for your chemistry test? Then this video is going to help you. Hello, my name is Vaibhav Bhattacharya and I am an excelling chemistry student. I am here to help you with all of your problems regarding organic chemistry. But today we'll be focusing on a specific family of organic chemistry known as esters. Let's begin. Hello there, I didn't see you. Now we're going to talk about esters. Esters are a family of organic compounds with the functional group COOR. There is a carbonyl group and an oxygen bonded, which is again bonded to an alkyl group. The general formula for an ester is RCOOR', and ester starts off with an alkyl group on the left hand side or the right hand side, and then there's a carbonyl group which is then bonded to an oxygen and another alkyl group. This can be a symmetrical or an asymmetrical ester based on what alkyl groups are joined. Now, esters are carboxylic acid derivatives, which means that when you react, esters are formed from a carboxylic acid, and they're also named on their carboxylic acid. So the carboxylic acid that they're formed from makes their last name. An ester, this is the full structural formula for an ester, where there's an oxygen bonded between two carbons with single bonds, and yes, there are lone pairs on this oxygen according to Vesper. Over here there's a carbonyl group which is then again bonded to other parts of the molecule. This is how you show a condensed or an expanded formula for an ester, where you, instead of showing the bonds for hydrogen, you just condense it and show it as CH3 line CH2. These lines show the links between each carbon. Over here, this is how you show a carbonyl group in an expanded formula, where you show C bracket O. And here, if you remove all the links, you get to a condensed formula of the ester. For this specific ester, there is 8 carbons, 16 hydrogens, and 2 oxygens. So its molecular formula is C8H16O2. Its empirical formula would be something different, but we're not focusing on that. Now, unlike other organic families like alkanes and alkynes, you cannot tell that this is an ester just by looking at its molecular formula. You have to draw the molecule out, and it has to be either a line diagram or a complete structural diagram that shows you that it's an ester. How do you identify an ester? You will see a carbonyl group and an oxygen, and then an alkyl group bonded to the oxygen. This is how you draw line structures for esters, where you show the oxygen and one of the sides has an alkyl group, just an alkyl group, or it could have any side functional groups, lower priority side functional groups. Over here you have a carbonyl group bonded right adjacent to the oxygen, and then another alkyl group. This is how you name, draw, and identify esters. Before I start talking about naming esters, I'm going to be telling you a little bit about reactions that esters undergo and can go under. Synthesis of esters. So esters are formed when a carboxylic acid and an alcohol react in the presence of sulfuric acid and heat. A catalyst like sulfuric acid. You can use something else. That's totally up to you. But iconically, textbook catalyst is sulfuric acid. So an alcohol reacts with a carboxylic acid to form an ester. Remember how I said that esters are carboxylic acid derivatives in the start of the video? I'll show you exactly what I meant by that. So basically what happens in this reaction is one of the OH from over here and one of the H's from over here come off as water. And this O goes and bonds with this carbon right here. That condenses the two molecules together to form what is known as an ester. And a byproduct of this reaction is water, which we don't really care about because it's inorganic, and our teacher said that inorganic byproducts are irrelevant to our reaction. Now, the same thing can go reverse, but you need a different kind of catalyst. Over here, you need H plus or a dilute acid. An ester is split off back into an alcohol and a carboxylic acid, which it was initially formed from. And the molecule is basically cleaved where that happened, the formation happened. This part becomes the alcohol, so all, and this part becomes the oic acid or carboxylic acid of the molecule. This is how the ester gets cleaved. Now let's go into the nomenclature of esters, where we're going to treat an ester as a new child that's named, that has a first name and a last name, the last name being its carboxylic acid parent, and the first name being its alcohol parent. Now I'm going to talk about nomenclature of esters. To name esters, you basically have to kind of split it into two parts. The part that came from the alcohol and the part that came from the carboxylic acid when this specific ester was formed, hypothetically. So first step is number the longest chain of carbon, starting at the carbonyl group and going away from the oxygen. So you want to name the carboxylic acid part. This part is the carboxylic acid part. I'm going to start numbering at the carbonyl group and away from the oxygen, so not that way, but number this way. This is 1, 2, 3, 4, 5, 6. That gives, and since it's in an ester, I have to add the suffix O8, and there's only one ester group, so it's O8. I'm going to say hexanoate as my parent chain name. And now I have to identify if there are any functional groups or substituent groups. Since this is the functional group, this is the main group that characterizes the compound, I have to identify the other could be functional groups as substituent groups because they're lower in priority than ester. This is benzyl on number 4, so I'm sorry, phenyl, my bad, phenyl. 4 phenyl hexanoate. That's my name for the carboxylic acid part. Now I'm going to name the other part of the molecule. So I'm going to name the alkyl on the group on the other side of the carbonyl group separately using IUPAC nomenclature. And these two names will kind of be separate from each other, but also be the whole name for the ester. There's not going to be a dash between this part of the name and this part of the name once I come up with that part of the name. Now I'm going to number from here, giving a lower number to the hydroxy group over here. So it is 2-hydroxy butyl. This is an alkyl group, and this is basically the whole name of the ester, 2-hydroxybutyl 4-phenylhexanoate. And that is how you name esters. Thank you, and have a good day until I see you again.
But wait, now that you know quite a fair bit about esters, there is a worksheet linked in the description. Fill it out, print it out, and keep it as a reference for future purposes. Thank you.